All right, hi, I'm Bruno. Pleasure to be here. How are you all feeling? All right, a lot of smiles, that's great, that's great. I'm gonna talk about what can you do with AWS and serverless AI and machine learning APIs, which fits really nicely with Mike's talk. So it's a nice continuation here. We didn't plan this, by the way, but it actually fits really nice. I work for a company called Futurize. Futurize is a software engineering and digital innovation consultancy company, headquarters in Helsinki, Finland, but we actually are in now 8 countries. We have a small office here in London as well, and we are around 600 people at the moment. Enough of that. The main question that you have in your mind is, who the hell is this guy? So a quick introduction about me. So my name is Bruno. I'm the principal architect and the technology advisor of Futurize. I've been working in different domains, such as cloud. I've been working with AWS for 5+ years, but also work with Google Cloud and with Microsoft Azure. And in Futurize, besides the cloud and DevOps, I also drive domains such as data engineering, AI, and security. My background is actually in security. I used to work for 7+ years in cybersecurity. So I have different angles to this talk and different angles to my role. And I want to tell you one story, and one story that happened in Futurize in the spring. So we were running with the customer this, let's call it innovation lab. So, like you crunch a bunch of ideas, and then you start trying out some of them to see what it works, what it doesn't work. And we run this with multiple customers. But there was one particular idea from this customer that was, crazy enough that we actually, all of us, including the customer, had doubts, can actually this be done? And will it be done what type of costs are we talking about if we try to do this? Where are we getting ourselves into it? So for a couple of days, I ran a smaller project, which was a technical feasibility study over that idea, meaning that, is this actually feasible? And, within okay budget, will this explode into a massive costs after a while? So trying to understand what do we have there and what we don't have and what is possible with the tools that we have. And we were in a fortunate situation that even though the customer was using AWS, the idea was so greenfield that we actually had the possibility to check what other public clouds actually have to offer on this. So we were not bound to any technology at this point. So the idea involved the concept of chatbots with a lot of sentiment analysis and a lot of translation. And chatbots were fairly new to me. I knew that there was some stuff in all the clouds, but I wasn't sure exactly what was there. I've been working mainly in data engineering, doing data lakes and data pipelines, and also in AI, but when you are actually training and classifying your own model. So I wanted to understand a bit what was available. So, I started by dividing the type of tools that you can find in a public cloud in 3 buckets. So you have in one bucket, you have the data engineering bucket, where you are ingesting data, you are doing the ETL process. And then in another bucket, the AI and machine learning platforms. So when you are actually building and training and deploying your own model. And then the third bucket was this AI and machine learning APIs. I knew that there was some work about chatbots and also sentiment analysis, but how mature were they? I wasn't sure. So on the first bucket, which was the bucket that I was mostly used to work, I started to map, okay, what are the technologies that we have there? And this might be very familiar to you already if you have been doing some data engineering work, which is that you are ingesting data, you are making the extraction, transformation, load, and then you are store them for a long period of time. You might have the need to store it in a hot way, so you have a data warehouse. You do analytics, you might do machine learning, and you will use SageMaker, for instance. So the tools for this are quite, they exist and they are there it was part of my day-to-day. How mature are some of them is a bit of a question mark at that stage. But on this part, I knew that all the 3 major public clouds they will have tools that allows us to do easily enough data engineering and AI in a level that we will be okay with it if we want to, train our model. But then I discovered on the chatbots, I discovered this serverless AI and machine learning APIs, which is this, ready-to-consume type of APIs. And I know that we are in an AWS event, but I'm actually giving you all the background from all the 3 public clouds. I hope you don't mind. I hope this is not too overwhelmed in terms of information, but I will narrow a bit to AWS quite soon, don't worry. So, and when I started to encounter this AI and machine learning APIs, I was, fascinated. I knew that they existed. I thought they were very immature, that they were not ready for production. I wasn't even sure, will I even trust these results? So, this is a bit of the journey that I was, when I was doing this, mapping this current state of the art, trying to understand what's the maturity of this. And in this APIs, there's a lot of AWS services. AWS and any kind of public cloud, actually, they are always delivering new services all the time. It's really hard to keep track of what is what. And I think you all feel this overwhelming sensation, even just if you are only working with AWS, that every month there's something new. And it's very hard to keep track. So I wanted to, at that time, and this was spring, I wanted to get this reflection, what is available, right? So on this level, I found these chatbots were actually quite common in all of them. At least on paper, Lex in AWS, Dialogflow in Google Cloud, and bot service in Microsoft Azure. They all offer this. But then also they all offer the same type of, image recognition via AWS recognition, translating between languages. If you are using, for instance, Google Translate, you are using the Google Translation API. That's what powers that, and that API is available to you there. But similar that if you are using text to speech and speech to text, there's a lot of things there. So the market it seemed quite mature on paper, that there's a lot of different possibilities. During the week that I did this, I was very oh wow, there's a lot of things to do. I'm very confident. But then I got thinking hey, I've been an engineer for many years, so I know that, sometimes what the brochure says versus what happens in reality is very different. And I think we all have that feeling that this looks really nice on paper, but is it? Is it actually usable? So I got home that weekend, and I was reading the news, and President Donald Trump was ranting about fake news. Fake news this, fake news that. And he was, accusing some, I know it's a fluff term, but he was accusing all these outlets about being fake news. And then I got thinking, I actually do know from, previous experience about fake news websites, real fake news, things that are not from credible media sources. And they look really different. So I was thinking hey, how hard will it be? What kind of information will I get if I just, throw a bunch of this, both credible and fake news data, metadata, to this type of APIs? What kind of things will I find? What kind of things will it tell me? I wasn't really interested in checking, is this fake or not? That was not relevant to me. I wanted to understand, I wanted to battle test this type of APIs and think, what actually will this tell me? So I started to gather, a bunch of stuff about media news. So, when you think about credible news media, in my particular case, I'm thinking about media outlets that are accredited by the press. So you have international press associations, and I'm thinking about media outlets that are accredited by that. I'm not thinking if it's, for instance, if CNN is fake news or not. To me, if they have a press accreditation, they are, of course, valid and credible. I'm thinking about all the other news outlets that spark, or that are not even news outlets, but are websites run by God knows who, that are sparked on the internet, that clearly have dubious type of information that keep flooding our social media. So you can actually see in the bottom some of them, and it's front page, right? National Report or Empire Earl, they're all fake, by the way. But this is the type of thing that you get. And if there's Darth Vader in one of them, for God's sake. Something is not right there. And even on fake, I was fascinated because fake can mean many things. It can mean satire. So for instance, like if you think like The Onion is not, it belongs to the fake news in this sense that is not a credible news outlet, of course, but in this case they are, upfront and they say that this is not real. But I'm thinking in all of those type of things that are not from credible sources, right? So I start as any engineer would, which is by extracting the data in the website. And this is not particularly fascinating, especially for this talk, but it is fairly easy to extract, data from a website. You can, fairly easy create, take the screenshot out of an HTML page. You can fairly easy take the text output of the website, and you can even scrape all the images that you can find in the website on the front page and store them. And that's what I did. So I started to gather this information. And I started with one website, which was the Telegraph. And it could be any website, to be honest. So I took that just to see what kind of metadata I could work on. And then with that metadata, so with a screenshot of the front page, so an image from the front page, with the text output from the front page, and with the children image that I could find, I started to run that with these APIs. And in all fairness, I started with Google Cloud, but that's not relevant for this talk. But I was so carried on that I end up using also AWS and Azure, and that's relevant for this talk, right? So with AWS, it was actually, the experience was super easy to get started with this. So in a way, AWS Recognition is the image recognition service, and you can just send the screenshot of the website, and I was getting this type of data. I know you cannot read it, don't worry, it's too small, but you were getting some labels, for instance, associated with the image. And then with AWS Comprehend, I could do sentiment analysis. I could check, based on the text output of this news, this is a very positive message, or this is a neutral message, or this is a negative message. So, first glance, it was actually quite interesting. I got more data than I was expecting. But then I started to, a lot of the things were coming neutral on the sentiment analysis, and it got me thinking like, this might not be correct, right? So I started to try like putting a lot of text, so a bigger blob of text, and then I started to run into some issues, for instance, in AWS that exceeds some limits in how much can you send at the first, on a batch to the comprehend. Also, then I started to bite it in chunks and only send a couple of lines of that text output. So I noticed that, there's some limitations with AWS Comprehend on how much you can send as a text blob. That limitation actually didn't happen in Google Cloud, for instance. It only happened in AWS, that I couldn't send the entire text. I had to send only subsets of that text. But then I started, getting all of this neutral, and I got really wary about, like, well, this can't be right. Why is everything neutral? So I started to play, instead of sending the text output from the news media, I started to send just sentences. So I started with, the first sentence was, hello. And hello came neutral. Oh, okay, I thought I was being joyful and everything. So I'm gonna start I'm gonna try something a bit different. And I put, drugs are good. And AWS agreed. And I was like, okay, you like to party? So what about drugs and violence are good? Also positive. Right? And I was like, can I trust this? So I started to challenge it a bit more. Drugs, crime, murder, terrorism, and violence are good. And in that AWS, it's neutral. So I lost a bit of confidence at this point in Comprehend, to be honest. And I was like, yeah, okay, this might not be, I will need to take this, even though I will analyze the text output of news, I will need to take this with a grain of salt because, you cannot, this might not be straightforward. I think the word good in this case, that's what, brings it up, the positive effect on the sentiment analysis. But it's still, I was very surprised with it. So, I started I need to And as any engineer working with public cloud likes to do, I need to start doing this in a massive scale. I need to try this with a lot of different websites. I want to gather as much data as I can to actually check if this is interesting or not, right? So, I gather like 10 websites for both 10 for the credible media, and you actually have the URLs there, and then 10 URLs for fake media. And there's a bit of a challenge with fake media, which is that some of the URLs, they only live for sometimes a couple of days or a couple of weeks because they are shut down very quickly. I was lucky enough that I run this every single day for 1 week, and they were all accessible, but there was some challenges with it, finding the ones that will actually live for that long. So I took this 20 websites in total, and every day I was visiting them. I was extracting from each of them this screenshot, child images, text output, and then I was running that data with those serverless AI and machine learning APIs. And this is what I found. So I will also give you some parts of Google Cloud just to have the term of comparison for you. But in AWS, for instance, on the text categories, on the fake news, I got a lot of, as an entity, I got a lot of dates. So it seemed that most of the fake news, they have a lot of timestamps or dates in the front page. So for instance, they have, for instance, this week something is going to happen, or in this particular date something happened. While on the credible news media, that actually didn't happen that much. I didn't got that much dates. I got some dates, but it was not so prominent compared with the other ones. Also, in terms of text entities on the fake media, there was a big chunk about Trump. And you can actually see the other entities. A lot of the dates were extracted. But on the credible news media, I did got a bunch of Trump, but also a bunch of Brexit. And the reason here was that this was April, so it was like everywhere in the media, this particular conundrum. So it was everywhere, the Brexit, so that's why I got a lot of that. But in a way, I was a bit surprised that was not on the fake media. It was only on the credible one. But Trump was in both. So it seemed that from this perspective, a lot of dates and Trump was that prominent in the fake media. In Google Cloud, similar type of comparison. Of course, the stuff that the API does is very different, but it's also extracting categories from text. And on the fake media, I got one part, a lot of was news and news politics, but then there was one part which was classified as sensitive subjects, and I didn't got that from the credible news media. From the credible news media, pretty much was news and news politics, and the rest was kind of quite okay. So from this perspective, I could actually get, just from the text, I could actually get that there's something a bit different between fake and credible already. Then I started to, from that text, to run the sentiment analysis. And here was also very interesting. The sentiment analysis, and of course take it with a grain of salt because you saw that drugs are good and whatnot. But on AWS, the credible news was getting neutral. Like everything was giving me neutral. But on the fake news, I actually got some of them, a small portion that was actually negative. And that didn't happen in the other one. So there was still a bit irrelevant, but there was only one part of it that was negative. And of course, since it's news outlets, I'm actually expecting that it should actually be neutral as much as possible, right? At least that's my expectation. In Google Cloud, fairly similar actually. I got, for the credible news, also everything was very neutral in terms of sentiment analysis, but on the fake news, there was some proportions of them that was fake. That was negative. And that only happened on the fake media. Now, on image recognition, things got a lot interesting. And AWS has something that the other two public clouds don't have in the image recognition, which is called celebrity recognition, which is super fun to use, by the way. So interesting enough, for the fake news image, for the fake news media, a lot of the I run the celebrity recognition on the screenshot of each website, and I got, you can actually see on the left side here that, there's a lot of actors, and on the credible ones, there's a lot of politicians, which was very funny to me that that only happened there. Of course, like you have on the fake media, the only politician that appears is the president of China, and that didn't happen on the other one. So it's the only politician that is recognized on the fake news media. So that was very interesting. Then also the moderation label. So when you are running this image recognition, you have like one subset, one flag that you can enable, which is that if you find something that is unsafe type of content, let me know what it is. That's in a gist what it will mean. And on the fake media, you actually got some of those returning as violence or graphic violence or gore, while on the credible news media didn't come anything. So everything was safe in terms of visual. So that was very interesting. Also that on the celebrity recognition, on the credible ones, and this was the week in April, Brexit was everywhere, and also, Trump has been everywhere as well. And both of them were recognized in the credible news, and that didn't happen on the fake one. In Google Cloud, so also a bit different results, but you need to remember that there's no celebrity recognition in Google Cloud. So you have, for instance, what you get is this categories, and some of them can be like safe search annotations, which is similar to what we got before. And here was spectacular. So on the top side is the credible ones. On the below you have the fake ones, and there was a lot of differences here. So on the credible ones, everything seemed all this safe search, all of the results came that, it's very unlikely that this will be, for instance, adult content or medical. On the fake one, you actually have things like very likely or likely to be, for instance, racy or spoof, and that didn't happen on the fake one, on the credible one. So, my conclusion of this is that, first of all, they're super fun to use. I think that's the thing that, I got a bit carried away while I was using it. So, it went way outside the customer project, and I ended up making it a bit of my hobby to do that, to run this by my own. But what I found is that these things are super simple to use, and people are not using it, and I'm not sure why, because you actually get a lot of valuable information from this type of APIs. So if you haven't tried them yet, go there and give it a try. You will be surprised by the type of results and easy to use. If you're using the AWS CLI, it's literally like one command to do something with it. So it's really fairly easy to start trying out this. And in this particular case, I only explore 2 APIs, which was the image recognition and the comprehend for the sentiment analysis. There's tons of other ones that you can do for other things. So thanks. Hope this was useful for you, and feel free to ask any questions. Thank you so much.